Hello everyone. So today we'll be solving a LeetCode medium problem, a beautiful array. Although it is tagged as medium, but to be honest, it is pretty hard. So let's see the problem statement. So we are given an array nums of length n, and now this array is beautiful if nums is a permutation of the integers in the range 1 to n, and there is no index k such that 2 into nums of k is equals to nums of I plus nums of j. So for example, if we have an array, there should not give means exist these three indices such that 2 into nums of k is equals to nums of I plus nums of j. Okay, so this condition should not be present out in all possible cases of this I, k and j. So for example, here in the input as n equals to 4, if we double this element, like 2 into 1 is 2, so there exists no pair such that the sum of those pairs is 2, right? Then for this element 2 into 4 equals to 8, there does not exist any I means indices on left and right such that their sum makes up to 8. Hence this is one of the valid outputs. So we are given an integer n, and we need to return any beautiful array of length n. Okay, so for example, here n equals to 5. So if we 2 into 1 equals to 2, so there exists no pair such that their sum is 2. Again 2 into 2 equals to 4, so there exists no pair such that their sum is 4. Here 10, so there exists no pair such that their sum is 10. So this is also a valid output. So hence, like we can see, means observe that this represents that we have three elements a, b and c, and such that 2b equals to a plus c. This condition should not be satisfied, and this means like abc, this abc are in ap, so no means it should not be in an ap, it should not be an ap, right? That is what we need to find, like this b here is average of a plus c. Okay, so like we can see, like this b is being multiplied by 2, hence that means like this middle number will be even. Okay, so what if we try to like find some way such that means the elements on the left and elements on the right, the summing them would never make the means sum as even. So for example, here the middle element, like mid equals to 2 into b, this is even, right? So what if, how will it make even? If you want to make a plus c, that means this should be odd and this should be odd, or this should be even and this should be even. This implies a plus c is even. So what if we avoid this condition? What if we like make a as even and c as odd, or make a as odd and c as even? In that case, a plus c will remain odd only. Alright, and since 2b is even, there will never exist a case where 2b is equals to a plus c. This will never occur. So hence, if we like means put all the even values together and put all the odd values together on the right or on the left, then so for example, if we put all evens here and then all odds here, and then we have b in the middle, means there will never exist a pair I comma j such that 2 into b equals to num of I plus num of j. This will never exist, right? So one observation we have made, like this we can like put all the evens on the left and put all odds on the right, or the reverse of it, like putting all odds on the left and b and all evens on the right. So we can do either of those things. Now another observation that we need to make is suppose we are given an AP, all right, so that 2b equals to a plus c. So if we multiply each element by 2, then also the means the elements remain in AP. So then also if we have 2a, 2b and 2c, then this condition is satisfied, like 2 into 2b equals to 2a plus 2c. This implies this 2 to 2 gets cancelled and again we get 2b equals to a plus c only. And also another condition is if we make the elements as 2x minus 1. So if this becomes 2a minus 1, this becomes 2b minus 1 and this becomes 2c minus 1, then what will be the scenario? Let's try to see. So 2 into 2b minus 1, and here we have 2a minus 1 plus 2c minus 1. So this becomes 4b minus 2 equals to 2a plus 2c minus 2. So again we get like 2b equals to a plus c. So hence we have seen like either we make the elements as 2x or 2x minus 1 if means if AP present, then even if we make the elements as this, still AP, right? So maybe we can reverse this. So if like AP not present, then we make the elements as 2x or 2x minus 1, still AP will not be present, right? And AP is not present, that means that our array is beautiful array, right? So hence if array is beautiful, then modified array or of 2x or 2x minus 1 also beautiful, right? So these are the two observations that we have made. The first one is this and the second one was we can put all evens together and all odds together, and if this array is beautiful and this array is beautiful, then so for example if we have two parts, this and this, and we have a part B shape. So if this is beautiful and if this is beautiful and this is all evens and this is all odds, then we can merge it as well. So this merging of both parts will also be beautiful only. Why? Because we have seen like means for even values there exists means since the middle part will become even 2 into x, hence there will never exist a pair which makes the sum as even, because on the left we have all evens and on the rights we have all odds, and separately these arrays are also beautiful, so they will satisfy the condition for each means each element separately here. So these are the two conditions that we have currently. Now what we are seeing is at each step, if you try to go in the reverse direction, if we want to do the calculation for a given n has n by 2 evens, and remaining would be like n minus n by 2 odds, right? So if we want to like find out the result for this n, then we need to like find out a beautiful array for this n by 2 evens and then find out a beautiful array for this n minus n by 2 odds. Okay, so these are all even numbers and these are all odd numbers, and once we have the result of these two, we can simply like means add them to form a bigger array, right? And then due to this condition that we had, we'll be able to satisfy the condition. So as we can see, like a means divide and conquer strategy is being uh, followed here. Like once we have this n by 2 events, we can break it into further, like n by 4 events, means new n becomes n by 2, and then we can have n by 4 events and n by 2 minus n by 4 odds and so on. Like so, and as soon as like n becomes 1, we can return a single element 1, which will be passed out. And how do we make these all elements as all events and these all right elements as all odds? So we can simply like multiply an array, any given array with 2. So this will be all events. And if we have any array and we make it 2x minus 1, then it will be all odds. And we knew that if this is beautiful, then making all elements 2x or 2x minus 1 is still beautiful, right? So this is the strategy that we'll be following in a divide and conquer method. So for example, if we had n equals to 3, let me show you for n equals to 2 only. N equals to 2. So what we'll do is n equals to 2. So we'll call the recursive function for two values. So here we'll have events 1 and odds 1. Now this, since n equals to 1, so we'll return 1 from here. Alright. Now since we need to return even numbers, so we'll multiply this array by 2. So and here we will get 2. We'll have multiplied this value by 2. And again here also n is 1, so we will be returning 1. And now since we need to return odd values, so we will be multiplying it by 2x minus 1. We're doing it this. So 2 into 1 minus 1 would be 1 only. So we will get array 1. Now we'll be concatenating it. So the result would be 2 comma 1. Alright. So hence n for n equals to 2, we get the result as 2 comma 1. Now let's solve for n equals to 3. Okay. So for n equals to 3, we'll be calling evens, we have 1, and for odds we have 2. And we know that for for n equals to 2, we have the result as 2 comma 1. Now we need to make it all odds. To make it all odds, we make it 2x minus 1, which becomes 3 comma 1. 2 into 2 minus 1, 3, and 2 into 1 minus 1, 1. And for n equals to 1, we get 1, and we multiply it by 2, so we get 2 1. Hence the result of n equals to 3 would be 2 3 1. Okay. Now let's also see for n equals to 4. For n equals to 4, we'll be calling evens 2 and odds also 2. Now for evens 2, for n equals to 2, we know the result is 2 comma 1, right? So here it will be 2 comma 1, and here also it would be 2 comma 1. Now we need to make it 2x minus 1, so the result will become 3 comma 1 here, and here we need to make it 2x, so the result will become 4 comma 2. Hence the overall array would become 4 2 3 1, as was the like output. Let's see what was the output in here. So it was 2143. So since there can be multiple solutions, here we have written 423. Now let's see for n equals to 5 as well, so that the approach gets into your head. So for n equals to 5, we'll be calling evens 2 and odds 3. Now for evens 2, n equals to 2, we'll get 2 1, we'll multiply it by 2, so we get 4 comma 2. And for n equals to 3, we have seen we get the array as 2 3 1. So we get the array as 2 3 1. Now we need to convert it to all odds, so we multiply it by 2x minus 1, so it becomes 3 5 and 1. Hence the resultant would be 4 2 3 So this is what the means will follow this algorithm in means recursive manner. We'll call the solution for means solution for n by 2 as well as n minus n by 2, and this will be even and this will be odd. And then we'll be means once the recursive call is over, we'll create a separate array which will have 2 into even and plus 2 into odd minus 1 new array. This will be a separate array and this will be a separate array. So let's see the code also. So this is the code. We have the base case as n equals to 1, where we return a single element 1. I will be calling a beautiful array of n by 2 for evens and a beautiful array of n minus n by 2 for odds. Then we'll create a separate result vector where we'll be returning back 2 into e, and from odds we'll be returning 2e minus 1, and hence finally we'll be return the result. So this is the code. The time complexity would be like at each step we are means dividing it into 2, then into 2. So hence maximum the recursive tree would go to log of 2, log n the height of the tree, and means yeah. So and the maximum vector we'll be iterating through is size n. So overall complexity is n log n here. So I hope like you get the approach. This is pretty hard getting the intuition, like if we have a AP, then thinking about if you multiply it by 2 and 2x minus 1, still it remains AP. Then reverse engineering this, like if it was not AP, then also it will still not remain an AP. So this was the main part in this question, and also identifying like we need to put all evens together and all odds together, and then means merging them. So these two were like pretty hard observations that we needed to make, and hence like it is tagged as medium, but this is a hard problem. Let's try to submit the code as well. So yeah, as we can see, like it runs fairly in 12 ms time. We can write the iterative version so that it beats more of the runtime, but that is fine. And login gets accepted here. And yeah, if you have any doubts, feel free to comment down and I will be happy to respond. Thank you for watching.